Okay, this is 6.1 in your textbook, page 264. Who would like to read the snowboarding blurb? I'd love to figure out how snowboarding is related to this. Henri, go ahead.
How can the owner of a snowboard rental business use mathematics to maximize the sale or minimize cost? What dimensions of a rectangular field provide the greatest area? Questions like these are answered by finding the maximum or minimum point of a quadratic relation, which occurs at the vertex. If a relation is of the form y equals a bracket x minus h to the exponent of 2 plus k, then the vertex is hk. However, if a relation is of the form y equals ax to the exponent of 2 plus bx plus c, the coordinates of the vertex are not so obvious. In this section, you will learn how to express y equals ax to the exponent of 2 plus bx plus c in the form y equals a bracket x minus h to the exponent of 2 plus a.
Good. So, in summary, we know that vertex form can tell us a couple of things, right? If we know the vertex of a quadratic equation, we can figure out either the max profit, if we're dealing with an equation with profit on the y-axis, or we can figure out max area. Okay, that's just kind of a blurb. So what we've learned so far with quadratics, okay, these are all different types of quadratics. Okay, this is what your course in grade 11 focuses on for a large part. There's a couple chapters that have to do specifically with quadratics, and you've already seen a lot of work. The first question to you, is there any, can you have the same parabola with the exact same graph with all three of these equations? You can tell me that. Just two people? Anybody else? Does anyone know this? These three equations, can they all relate to one graph, one and the same graph? Yeah. Luigi?
Yes.
They can, right? So all we've done so far, when we factored, we learned how to factor. We converted standard form, we converted it into factored form by this process called factoring. Okay, that's how we got from standard form to vertex form. We spent a whole chapter doing that. Okay, we saw different variations of standard form. We saw when standard form, when the a value was 1, when the a value wasn't 1, when it was a perfect square trinomial. Okay, when there was a difference of squares. These are all different types of standard form. And we learned how to factor them. We moved them from standard form to factored form. What is it called when we go from factored form to standard form? Kyle?
Simplifying.
Yeah, it's called actually two words, expand and simplify. Okay, and one of the tools we learned how to do in order to do that, or what do we call it? There's a name for it. Tiago, do you remember? When you were multiplying two binomials, there was a word we used. No idea? No, Josh?
FOIL.
Yeah, FOIL was the word, okay? But kind of more accurately, we used the distributive property, okay? Where we distributed the first term to the binomial and we distributed the second term. You remember that, Luigi? FOIL?
Yeah.
Oh, sorry, Tiago? Yeah? Okay, so when we expand and simplify or we FOIL, that's how we get from factored form back into standard form. Okay, so this we spent a long time doing. What we haven't done really is we've learned a lot about vertex form. Okay, and we've learned why it's probably useful. But we haven't learned how to get from standard form to vertex form. Have we learned how to go from vertex form to standard form? To get from here to here? Gianluca?
Yeah.
How?
By.
Sorry?
I don't think we did.
No, you were right the first time. Eddie?
So you factor the.
No, you don't factor. Factor's going this way. Just get from here, guys, to here. Daniel?
You have to do the x minus h squared. You break them up.
Yeah, so what are you actually doing when you break it up? You're Henri?
Expanding it.
Yeah, and then at the end you're simplifying. So it's actually the exact same thing we're doing, right? So this goes with this, right? We have this motion. You're expanding and simplifying. You're also using FOIL here for this term, right? Okay? So that direction getting back to standard form is the same process. All right? What about going from standard form to factored form? We learned standard form to vertex form. Standard form to vertex form. Yeah?
You factor it.
No, you don't factor it. That's how we get to factored form. Luigi.
So from the bottom to the second one?
No, from the top to this one.
Oh, from the top, you expand it.
Okay, so you expand standard form? You can't really expand it. It's a bit of a trick question. I don't know if anyone's going to get this, all right?
Can you group it?
No? Matthew?
Decompose it.
No? That's still a factoring. The reason why you guys don't know is because that's what we're learning today. Okay, this is 6.1, and it's called completing the square. I was just seeing if anybody had actually heard of that or seen that before. Okay, so to get from standard form to vertex form, we complete the square. That's this process. What about vertex form to factored form? Dom?
Factoring?
You're right, factoring, but you've got to go somewhere else first. You can't go right from here to here.
You have to go to vertex to standard, and then you can do it.
Yes, good. So in order to get here, you'd have to go like this. Okay, up to standard form, and then factor back down. Okay? But there's not a big reason to go from vertex form to factored form. And I'll tell you why, because a lot of the questions we have, we really want vertex form. So that gets us into the reasoning, why are we doing all this? Just, can anyone tell me, what is the point of all this? Why are we fooling around with the format of the way we're expressing our quadratics? Why not just leave it in standard form and be done with it? What's the point? You guys are learning all these things factoring. At the end of the day, we're not changing anything. We're not changing the equation. All we're doing here is rearranging. At the end, I have not changed this expression when I factor it. I hope that's clear. You guys have not changed it. If we have, then we change the actual way it looks on the graph. We don't want to do that. We're just moving things around. Why? What's the point? Daniel.
Make it easier to graph.
Easier to graph. Okay. I would partially agree with you. Part of it is to make it easier to graph. All right.
So that the equation shows different parts of the graph?
Excellent. Yes, exactly right. So the equation shows different parts of the graph. That's a perfect answer. So in standard form, what do we see on the graph? Matthew.
The path of the parabola.
Like through.
The path of the parabola, we see that on all the graphs, but what does standard form tell us about the graph?
It's compressed or stretched.
That tells us every one. A is the same. Compress or stretch. For vertical compression or stretch, it's the same. What does standard form tell us that these two don't? Right away, just by looking at it.
The y.
Good, the y-intercept. That's what I was looking for. Y-intercept. Okay, so that's standard form. I'm going to put it up under here. Y-intercept. Okay? Nicholas, you're going to tell us what vertex form tells us.
Which one?
Vertex form. What do you think the vertex form tells us?
I mean, which Nicholas?
You.
Oh.
I'll give you a hint. The answer is in the question. What does vertex form tell us about the graph?
Tells us what the vertex is.
Yes, good. It tells us the vertex. Brilliant. Anything else? It also tells us the A value, which all of them tell us, so I won't mention that. Anything else that's important? Not really, right? Vertex is a big one. Okay? You could also say it tells us the axis of symmetry, if you want. Okay? That's a question. Right away we can see the axis of symmetry. It's x equals h. Okay? Those might be the two things I mentioned for vertex form. In factored form, what does it tell us? Sebastian.
I don't know. I forgot.
Forget? Think about it. Yeah?
The x-intercept?
Good. X-intercept. Anything else? It also tells us the value of A, but we know that from all the other equations. Anything else? There's another thing I want to mention, yeah.
The x value of the vertex.
Okay, good. X value of vertex. That's important, okay? And that is R plus S divided by 2. Okay? Why is that important? Because it allows us to find the vertex relatively easily. Okay, that's important. Okay? So all of this and everything that we're talking about today, the reason for it is to be able to identify the vertex. So if we can get to vertex form, we can see it right away. Okay, so that's the whole point of what we're going to learn today. We're going to learn what's called completing the square. And what completing the square does, this will be a great communication question on your test, is what is the point of completing the square? Or why do we use completing the square? The answer is we use completing the square to go from standard form to vertex form. Okay, very important to understand it and know that. Okay, so let's look at completing the square here. First, we have the definition. Completing the square, a process for expressing this, which is standard form, in the form this. All right, so this is standard, and this is vertex. That's all it is. Okay, and all factoring was going from standard to factored form. All right, so if we look on in our textbooks now, example 2. It's on page 267. It says find the maximum or the minimum point of the parabola with equation. So who can give me an idea before how to do this without completing the square? So what you guys know right now. How do we find the maximum point? Or first of all, what am I talking about when I'm saying maximum or minimum point? Connor. On a parabola, Connor, so it's either looks like this or like this, right? When I'm talking about the maximum or the minimum point, what am I talking about?
Vertex?
Yeah, the vertex, exactly. That's all I'm asking here. Okay? Find the vertex, the maximum or minimum point. It's a fancy way of saying find the vertex. Okay? Because we know the vertex is always going to either be the max or the minimum. Okay? So if it says find the vertex, how would you guys find the vertex of this? There's a couple ways to do it. Only one guy. Two, Andy.
So you try to split the x squared.
You split the x squared? What do you mean? What do you mean? I don't know what you mean, split the x squared.
Like try to square root.
No, don't want to square root that. Daniel.
M&A?
M&A, good, yeah, that's one way.
There you go.
So you do M&A and you factor, right? Okay, in this case it would have to be decomposition because the first term is not 1. Okay, so M&A, you factor, but you still don't have the vertex. What do you do to get the vertex? You had a great idea, use M&A, but we're asking for the vertex, so that doesn't give you the vertex. What do you have to do after that? Come on, guys. You have it in factored form, okay? So you're down to here. Now you want the vertex, right? Just Matthew? Yeah?
You would get it into factor form using M&A.
Yeah, and then what?
You would have to find what makes each bracket 0, so it would be the negative of the other number, and then you'd have to find x-axis of symmetry,
Yeah.
and then use that x in your equation.
Right, so you're using kind of this formula to find out the x value of the vertex, and then you're plugging that x value in to get the y value. You guys understand that? Okay? It's review, right? You guys should all remember that, right? I hope. The other way that you learned in grade 8 to get the vertex of this, old school.
Graph it.
Yeah, how do you graph it? You use something called a
Table of values.
TOV,
Table of values.
table of values.
Oh.
You guys remember this?
Yeah.
Remember, it's old school, but it works, right? You put down the y and the x, And then you throw in numbers for x and you find out what y is, and eventually you'll get a graph that looks like this and you find the highest point, okay? So you have two options already before I teach you today's. But the point, like in all mathematics, as you get more and more advanced, you get kind of to your answer faster and faster. You find shortcuts. Okay, that's what completing the square is. It's a long process to factor this and then find out the x-intercepts and then add them together and divide it by 2, then plug it back in. It's a lot of work. So we're going to learn the completing the square method today. So here's how it works. The first thing you want to do is you always want to factor out whatever is in front of the x squared. Okay? That's the first step. You're going to partial factor, it's called. So you're partially factoring only the first two terms. You don't factor out the last term. It does not have to be common between all three terms. It doesn't have to be common between the first two terms. Doesn't matter. Whatever it is in front of the x squared, you're going to take it out. You're going to factor it. Okay? What I mean by that? So it's a 2. The 2 is going to drop down. I'm factoring the 2 out. So when I factor out, I divide each term by 2. So this is going to be 2x squared divided by 2. You're going to be left with x squared. And then 12x divided by 2. So you're going to be left with plus 6x. Any questions just to there? That's all I've done so far. Is I've taken whatever the a value is. If it was negative, I would have taken a negative. And I've divided it out of the first two terms. Any questions there? No. Okay, it's going to get strange now. It's going to get weird. Now, you guys have learned about perfect square trinomials, right? Who can tell me what a perfect square trinomial is? Come on, guys. Gianluca?
When the first and last term are squared, then you just can get a shortcut to make them into
Yeah, when the first and last term, and then the middle term has to be?
the 2a.
Yeah, 2 times the square root of the product of the first and last term. Okay, good. You don't have to memorize that to know what to do next. Once you're here, you're going to add half of the middle term squared. So half of 6 is 3 squared. Okay? And then if you're going to add that number, you have to subtract it. Okay? Because you can't change the equation. And I know it looks weird at this point. You're just adding random numbers and then taking them. Perfect square? Yes. Perfect square? Yes. Square root of this, x. Square root of this, 3 times 2 is 6x. So it's a perfect square trinomial. And I know that because I've created it. I've chosen this number. So it always will be if you've done everything right. So this becomes x. This sign drops down. If that's a negative, you'd have a negative here, but it's a positive. It drops down. And the square root of this, plus 3 squared. That's the shortcut, right? From perfect square trinomial. From that to that, we've learned that. And finally, I combine the 18 and the 11 minus 7. And then, voila, you're in vertex form. Okay? Any questions there? That's all there is to it.
What
Yep.
do you do with that step in between the last one and the second one?
From here to here?
Yeah.
Yeah, this is the shortcut you have to know, okay? It goes based off this equation, right? That's the equation for the shortcut for a perfect square trinomial. Okay, you just got to remember that. It's just the square root of this, the square root of this, and this sign drops down, squared. Okay? Yeah.
Is it always 3, or is there like a certain pattern about that?
No, it's always half of this value squared.
Oh.
Okay, so if this was 25, it would be 12.5 squared. Okay?
How
We're
about
going to
that?
show you a couple more examples.
That's interesting.
All right, so this is example 3 on page 268. It says path of a ball. Sebastian, can you read at the top, 268?
The path of a ball is modeled by the equation y equals negative x squared plus 2x plus 3, where x is the horizontal distance in meters from a fence and y is the height in meters above the ground. what is the maximum height of the ball, and at what horizontal distance does it occur?
Okay. Thank you. Sorry, I'll stop you there at A. So it's asking the maximum height of the ball for this equation. So Luigi, what is it asking for?
It's asking you for the maximum of the y.
Yeah, what is that called? What's another name for this?
It's the maximum. The maximum.
What's the equation that we've come
Oh, it's
to?
vertex y.
It's the well, it's asking you for the vertex, right? Okay, it asks you for the maximum height of the ball. Well, it's asking you for the y value of the vertex. Okay, because it told us y is representing the height. All right, so for this, then we need to complete the square. So the process is y is equal to whatever's in front of the x squared. I don't care if it's a -2. I don't care if it's a fraction. I don't care if it's a decimal. I don't care what it is. I'm going to factor it out. -1 in this case. Okay? So my first term in completing the square is always x squared. Why? Because I chose to factor out -1. So I'm making sure that this is always x squared in the brackets. If you have a negative sign here, you've done something wrong. Okay? So you're always factoring out the a value. In this case, it's -1. So now to factor out -1 from the second term, I need to divide 2x by -1. So I get -2x. Okay? And I don't factor the 3. I do not factor the -1 out of the 3. It's partial factoring, remember. So the 3 can stay all the way over here. Every time. That doesn't change. That last number is away from what you're doing. Okay? It stays out of the brackets. Next step. I need to do what? Who remembers? Tiago.
Half of 2x squared.
Okay, what is the half of 2? Don't worry about the x. What's half of 2? We're just always adding a number, never a variable. What's half of 2?
1.
What's 1 squared?
1.
Okay, it is just 1, but I'm going to leave the square in there just for show. It's +1 minus 1.
Or is it always plus the number of maximum?
Yes, always plus first, minus second. Always. Yep.
It's a negative?
Even if this is a negative? Yes. You always add the number, take away the number. That's important. Okay? Because the reason why that's important is because in a perfect square trinomial, you can't have this shortcut if this is a negative sign. Perfect square trinomial, that has to be a plus. So that's why you're creating that first number as a plus. Okay? All right, so now that that's done, I need to release that last number. So I leave everything else the same. I've created my perfect square trinomial already. And now I just need to multiply -1 times -1. So that becomes +1. So now I have -1. I'm done. The last step is now I take the square root of the first term, drop the sign down, whatever it is there, square root of the second term, square plus 4. Done. Okay? So my vertex then, is going to be 1, 4. Matthew.
Before you take 1 squared out of the bracket, you multiply by the coefficient first, then square.
No, you square first, like bedmass. So it would be -1 squared, or in this case, it would be -9 times 2, -18. Okay?
So wouldn't that be -1?
No, because it's -1 times -1. Yeah, be careful. Okay, I see your question. It's not -1 squared. Okay, that's a good question. See how he's asking, is this a positive value? No, it's not. It's -1 squared. Remember, this is that. This is that. There's a difference. Okay? We can't say that it's +1 here because then I would be adding 2. I'd be +1 plus 1, right? It's always a negative number here. Always, always, always. Even though you see the square, it's still negative whatever that is squared. Okay? Because you're adding that number, you've got to take away that number. So it might be less confusing if you do this. +3 squared minus 9. Okay? That might be a better way to do it. Alright? Plus, keep it in a square format because you're going to use that 3 later. And then minus 9. I don't know if that's confusing to you guys. You realize that's the same number, but that might be better. So then, what is the maximum height of the ball at what horizontal distance? This is my vertex. Okay? The max height of the ball, max height, it tells us is the y value is the height. So max height is 4 meters at 1 meter horizontal distance. Okay? Because that's what the question asks. It says, y is your height, so y is 4, max height, when x is 1. Sketch a graph to represent the path of the ball. So you guys would sketch this graph, and the vertex is 1, 1, 2, 3, 4. So there's your vertex. It opens down, or something like that. And then you can do your step pattern, right? Your A value is 1, so your step pattern is going to be 1, 3, 5. So you go 1 over here, 1 down, 1 over here, 1 down, 1 over, 3 down, 1, 2, 3. So your graph would look like that. Okay? Any questions? All right, last, you guys want to see a couple more just simple completing the squares?
Yeah.
Yeah? Okay. I think that might help as opposed to the max revenue question. You want to see a word problem or a couple more examples just completing the squares? Both? All right, I'll do 2 completing the squares quickly, and then the last word problem. Okay, very quickly now, let's do this. So the first one, my A term is just 1. So I don't care what it is, it's still coming out. 1, I'm going to factor the first 2 terms. They don't change because I'm just dividing them by 1. Now I'm going to add half of the middle term squared. So plus 1 squared minus 1 squared, right? Minus 1 on the outside. Now I need to get rid of this negative 1, so I multiply it by what's in front of the brackets, which is 1. So this stays the same. 1 times negative 1 is negative 1 and negative 1. So my final answer then is square root of this. Drop this sign down, square root of this, squared minus 2. Okay, any questions? It's an easy one.
So can you do like a hard question?
Yeah, this one is harder. These are progressively harder. So here I have 3x squared. I want to factor out the 3, whatever it is. I'm left with x squared. My first term is always x squared. 90 divided by 3 is plus 30x. Now half of 30 squared. So plus 15 squared minus 15 squared. And on the end, plus 15. 3. Now I want a perfect square trinomial, so I write the trinomial, the first 3 terms. This last term I need to multiply by 3 now. So it's going to be negative, because it's a negative, 3 times 225, right? 15 squared. So what's that? 675? You can do that on your calculator, right? 3 times negative 15 squared. Be careful with that. Make sure your calculator doesn't do this. Make sure it doesn't change the sign to positive. Okay, you gotta be careful with that. So you might wanna do 15 squared first and then times 3 and make it negative. That would be one hiccup, I would see. Sorry?
225.
Yeah.
Times 3.
Times 3.
Yeah, that's right.
Is 675 right?
You're asking, yeah.
Yeah, that's right.
That's right, okay. And so finally, the last step, 3 stays on the outside, square root of this, x. That sign comes down, square root of this is 15 squared minus 625. Any questions there? Is this helping?
Yes.
Yeah, okay, one more, this one. Okay, whatever's in front of the x squared, I don't care what it is, it's coming out, negative 7x squared minus now, minus 2x, because 14x divided by negative 7x. Now I'm going to add half of 2 squared, again it's a 1. Negative 1 times negative 7 is plus 7 minus 3. Square root of this sign comes down, square root of this, squared plus 4. Yeah?
Is there ever going to be a question where the first number can't divide into the second number evenly?
Yes. I'll show you that right now. There's not many of them in your book, but it shouldn't matter. Okay, here. Okay, so this one is all decimals. You would need a calculator. You guys can imagine if you were trying to factor this with M&A, it's just not possible, right? M&A only works with whole numbers. So in this case, you're only left with this option or else the table of values, which would take much, much too long. So you're only left with completing the square. Nice thing about completing the square, it works for any numbers. It doesn't matter. So your first step, you factor out whatever's in front of the x squared term. So x squared is left. Now 4.3, 1.6 does not go into 4.3, does it, evenly?
No.
No. So what's 4.3 divided by 1.6? I need help.
You have to put it down there.
0.1875.
So it's going to be negative because it's positive 0.3. 0.
One. Oh, sorry.
No.
Just delete
No,
it.
it's negative.
It doesn't make sense.
That
No,
doesn't
no.
make sense.
4.3.
I got negative 2.68.
That sounds
Yeah.
Makes sense.
Negative 2.6.
Oh, sorry, yeah.
Probably
4.6.
75, sir.
Okay, 688. Go 3 decimals, okay? So this divided by this is how we factor, right? We divide it out, right? So negative 1.6 divided by negative 1.6 is 1. 4.3 divided by negative 1.6 is negative 2.688. Now we got to add half of this squared. So I'm going to say plus 1/2 of this is going to be 1.344 squared minus 1.344 squared. And then on the end, minus 5.2. That end term still goes way out. And now, negative 1.6 x squared. I leave the first 3 terms. So what is negative 1.6 times negative 1.344 squared? Ace? Calculator? Somebody?
Say it again, say it again.
Right here. This times this.
8.
Oh, okay.
Come on, Fanny.
You guys aren't doing this? No? Not bothering?
2.1504.
Yes.
So positive
2.1504.
No, it wouldn't be negative, right? Because it's a negative times a negative, so it would be positive. No, I heard somebody ask that. And then finally, minus 5.2 on the end. So last step, negative 1.6, square root of this, x, square root of this sign drops down, square root of this, 1.344 squared. And now just